Hi there! Today I'm going to show you how to create an implementation of the game Simon using Phaser 3. This video is part of our game prototyping with Phaser 3 series, and the goal of this series is to create a very basic implementation of a game to get the high level of the game down with the basic game elements. And then you would take that game on your own further in order to create a fully fledged game. So on the screen here you can see an example of what we'll be building today. So if you're not familiar, the game of Simon is a simple game where a series of sequences are played back to you, usually with an audio and visual cue, and your job is to remember what was played back to you, and then you repeat that pattern. And then over time, that sequence is going to get longer and faster, and you need to go ahead and remember that sequence and play it back. And overall, your goal is to get the highest score possible for your longest sequence. So in order to create our game, we'll be taking a look at basic shapes in Phaser and how we can create simple squares and use the built-in methods to modify our opacity and add interactivity so we can hover over them, and then we'll change our opacity. We'll be looking at how we can use audio game objects to play sounds in our game. And then finally, we'll be looking at building a Simon class that's separate from our Phaser code so we could reuse it across other various frameworks. To get started and to follow along with the code, you will need to go ahead and download a new instance of our basic Phaser 3 TypeScript template. In the description of this video, there will be a link to download this template from GitHub, and in a previous video that I'll be sharing, I discussed how we will be using this template in our video series on creating game prototypes with Phaser 3. There'll be a link on your screen now as well in the description of the video, and in that video I cover where you can find these project file templates on GitHub, how you can download and set up the project locally, how you can go ahead and install the project dependencies and then run the project locally, then view the Phaser 3 game locally on a dev server. We then reviewed the project structure and talk through the underlying code that makes up the basic Phaser 3 game. If you're interested in learning more about this template, I definitely recommend checking out that video now. So in this video, we will not be reviewing the project template or how to run the project locally. Once we get to the coding section of this video, we are going to jump right into the code. Before we dive into our code, we're going to go ahead and review what task we will need to complete in order to create our prototype. So for our game of Simon, the first thing we're going to do is we're going to download some additional assets. So in Simon, one of the main things is you have an audio cue for when we're playing a sequence. And so we'll download some audio and we're going to add those to our prototype. Then we're going to go ahead and update our initial game configuration from our project template. We'll load in our audio assets, and then we're going to start creating our game. And so we'll start off by creating our buttons in our game by using some basic game objects. We'll add in our hover events on our game objects to change our color alpha. And then we're going to pause working on our game logic, and we're going to focus on the core logic for the game of Simon. So we'll be building a new class, and we're going to focus on generating a random element from our sequence. We'll add in our methods for handling player input, and then track our player input until either a sequence is matched or mismatched, and then that way we can update our game state to either be game over or play the next element in the sequence. Finally, we'll add in some code to go ahead and allow us to reset our game state so we could easily restart the game. Once we have our core Simon class done, we'll need to connect that to our actual Phaser 3 scene, and we'll add in some simple state tracking to know what our overall game state is. And so then that way we'll know if we're waiting for player input, if we're now playing a sequence to the player, and so we should lock our input. And then finally a game over state, so that way if the player lost, we would allow them to reset their game. Once we do that, we're going to add in our code for playing our first sequence, and so that's going to go through, and in the demo it's going to go ahead and play our audio as well as make our button like flash. And then finally, we'll go ahead and add in logic for handling player input and for connecting that to our playing our sequences. All right, so the first thing we need to do is we need to download our additional project assets. So in the description of this video, there's going to be a link to a direct download, which is going to be the Simon Assets zip folder. If you can go ahead and download that, that's going to have a subfolder called Assets with 4 audio files. So if you can go ahead and download that now and extract it, what we'll want to do is place that in our public and then assets, and we should have an audio subfolder with those 4 sounds. Alright, so now that we have our project assets, we can actually start working on our code. So the first thing we're going to do is update our game configuration. So if we can go into our source and our main.ts file, what we'll want to do is we're going to update our width and our height of our canvas element. And so we're going to go ahead and do 450 by 450 pixels for our game. And so next we'll want to go ahead and load in our assets that we added previously. So if we come up to our game scene class, what we'll do is in our preload method, this is where we're going to go ahead and load in our assets. And so what I'm going to go ahead and do is, because we're going to reference our asset key in a few locations, we're going to go ahead and create a variable to store these. And so what I'm going to do is I'm going to do const, and we're going to do asset keys. And we'll set this equal to an object. And we're just going to, for our keys, we'll do sound1. And for our value, we're going to do the same thing. And so we'll have a string, and it'll just be sound1. And what I'm going to do is I'm going to copy this, and we're just going to do this for our 4 sounds. And we're going to have 2, 3, and 4. And then what I'm going to do is I'm going to do as const, and then that way we can't modify this object. So then with our asset keys defined, down our preload, what we'll do is we're going to do this.load to reference our loader plugin. And then from our loader plugin, we're going to go ahead and load in an audio file. So when we load in our audio file, we'll need to provide our key, so our asset key that's going to be associated with this data we load. And so we're going to use our asset keys const that we created previously, and we'll do sound1. And so by putting this inside an object in a variable, now when we want to reference this audio later, we can use that same variable, and we don't have to remember what string we used. So after we provide our key, we need to provide our URL to where our asset is actually stored. And so this is going to be under assets, and we'll have audio, and it's going to be Simon sound1, and it'll be an MP3 file. And now we have 3 other files, so I'm just going to copy this line, we'll paste it 3 more times, and we'll update our keys and our strings. And so we'll have 2, 3, and 4. And same thing for our actual file names, it'll be 2, 3, and 4. Alright, so now that we load in our assets, next we need to start creating our button game objects in our scene. So to go ahead and do this, let's come down to our create method. And for our game object, we're going to be using a simple phaser 3 rectangle game object. And so go ahead and create this. What we're going to do is in our create method, we're going to go ahead and make a new variable. We're going to call this button, and we're going to set it equal to this add, and we're going to reference rectangle. And so this is going to create a rectangle game object from our game object factory. And for our game object, we need to provide our X and Y values of where we want this object to be placed in our scene. And so we're going to do 20 and 20 for our X and Y values. And so for positioning, our top left-hand corner is going to be 0, 0 for our coordinates. And as we move right across our canvas, that's going to be a positive X value. And as we come down, that's going to be a positive Y value. And so in theory, we're going to position our game object about like right here. So after our X and Y values, we need to provide our width and our height of our rectangle. And so we're going to do 200 pixels by 200 pixels. And so that's going to give us a square by using a rectangle game object. And then we need to go ahead and provide our fill color that we want to use for this game object. And so for this, we're going to do 0x db 0a 8b. And then I'm going to go ahead and save. And so what we'll see is we now have a small square added to our scene, but it's much smaller than what we were expecting. So in our game configuration, our width and height are 450 pixels. And with this being 200 pixels, it should take up almost a quarter of our scene. So what's happening is when your game objects are created, by default, your origin is in the middle of your game object. And when you place your game objects, Phaser uses that origin for placing those objects. And so either we could update our X and Y values to move our game object over, or we could modify the origin on our game object. And so that's what we'll do. So we're going to call set origin, and when we do this, we can provide our X or Y values optionally, and we're going to use 0. And by providing 0, this is going to set our origin for both X and Y to be 0, which is going to be the top left-hand corner of our game object. So now when we move our game object, it's going to use this origin here in our corner. All right, so now we have our first game object. We need to actually create 3 other buttons. And so because we have our overall code down, we're going to go ahead and create a method to abstract away this logic. So we're going to have to do additional things with our buttons here in a bit. And so what we'll do is we'll make a new private method in our class, and we're just going to call this create button. And so for this method, we're going to return a phaser game objects dot rectangle for what we'll return. And we're just going to copy this line of code here, and then we're going to go ahead and return our button. And so for our button, for our method, what we need to do is add in our parameters that we're going to expect. So we're going to expect our X value, which will be a number. We'll need a Y position, so that's also going to be a number. And then we're going to have our color, which will also be a number. So what we need to do is update our call here to use our new arguments. And so we'll do X, Y, And we'll keep 200 for our size since this won't be changing. And then we just need to change this to be color. And what we can do up here is replace this logic with the call to our method. So we're just going to put that down, and we'll do this, create button, and we want to do 20, 20. I'm just going to copy this color here, and we'll go ahead and paste it. Let's remove that line of code, and if we save, we should still see our game object. So then what we want to do is we just need to create 4 buttons, and so I'm just going to copy this line of code here, and we're going to do this 4 times. And so we'll have our 4 buttons, and we'll update our variable names. So we'll have button 1, button 2, button 3, and button 4. And so for positioning on our second button, we want to go ahead and do 230 pixels over. So we're going to move this game object over, but do the same Y value. But then for our other game objects, we want to go ahead and use the same X value for positioning them, but we want a different Y value. And for our Y value, we're going to do 230 to bring those squares down. Let's go ahead and save. We should now have 4 square objects in our scene. Now we just need to modify our color. So for our second button, we're going to do 0x, 08, C, 418. For our third button, we want to do 0x, E6, E600. For our fourth button, we're going to do 0x, 0066, CC. And so now we'll have our 4 different color buttons in our scene. So one last thing we need to do is for our buttons, we're going to go ahead and modify our alpha on them so they're not so bright. So in Simon, typically our button's going to flash and light up when that's the sequence that we need to follow. And so we'll want to be more of a dull color, so then that way it's very evident to the player which button they need to interact with. And so we're just going to use the set alpha method to modify the alpha on our game object. So this is going to be the opacity. By default, it's set to 1, and so then that way it's not opaque at all. But now if we set this 0.4, we see now they're more transparent and they're more dull. So one last thing we're going to do for our buttons is we're going to go ahead and create an array to go ahead and store these on our class, and that way we can keep a reference to them in our code. So what I'm going to do is we're going to add a new property to our game class, and we're just going to call this buttons. And this is going to be a type of phaser game objects, and it'll be a rectangle game object. It's going to be an array. And then what we'll do is we're not going to initialize in our constructor, so we're just going to add that flag. And then after we create our buttons, we're going to go ahead and add them to our array. So what we'll do is we'll do this, we'll do our buttons, and we'll be equal to it'll be equal to an array of our buttons. And so we'll have button 1, button 2, button 3, and button 4. So now that we've created our initial buttons, the next thing we need to do is we need to make them interactive, and then that way we can listen for various events in our game. And to go ahead and do this, what we'll do is in our create button method, we're going to go ahead and call the set interactive method on our game object. And what this does is this will tell Phaser to allow us to listen for input on these objects, and it'll emit events we can listen to. And so like when the player hovers over it with their mouse or they click on it with their mouse, we want to be able to know when that happens in our game. And so by calling this method, this will allow us to register event listeners. And so to go ahead and listen for an event, what we need to do is on our game object, we're going to use the on method to reference our event emitter that's tied to that game object. And then with that emitter, we can provide which event we want to listen to. And so the first event we're going to listen to will be our pointer over event. And so that's when our mouse goes over an object in our game. And so we'll do phaser, we'll do input, we'll do our events, and then we'll do our pointer over event. So then we'll want to go ahead and provide a callback for what we want to do once this event is fired. And so what we're going to do is we're just going to type this as a string, and that way that's happy. And what I'm going to do, I'm just going to console.log, and we'll say mouse over. And then we can also do one for when our pointer leaves our game object. And so if we just go ahead and copy that block of code, let's do pointer out, and we'll just do out. If we go ahead and save, now if we come back to our game, we'll see now as we go over our game objects, our various console log statements are triggering. So one other event we'll want to listen to in our game is when we actually click on one of our game objects, and then that's how we'll know if the player is choosing that for the button in their sequence. So I'm just going to copy this block of code. It's going to be very similar, but the event we want in this case is going to be our pointer down. And so our pointer down event will only fire once we actually click on our game object or we touch it. Oh, and let's change our console log statements. Instead of mouse out, we'll say mouse down. And now when we click, we can see the differences in our console log statements. So now that we have our core event listeners working, what we actually want to do is when the player mouses over one of our objects, we want to go ahead and highlight that object so then that way the player knows they're kind of interacting with it. And for that, what we're end up doing is we're going to modify our fill color on our game object so then that way it's a little bit brighter. And so to go ahead and support this, we want to go ahead and update our method to have one new property, and we're going to do hover color. And so for our hover color, this will also be a number. And what we'll go ahead and do is up here, let's go ahead and add in that. So for our first button, we're going to do 0xF535AA. And then what we'll do is we're going to do 0x16F529. And then we'll have 0xFFFF33. And then here we're going to have 0x1589FF. So when our mouse goes over the game objects, we'll want to update our color. And to do that, we can just reference our game objects. We're going to do button, and we'll do our fill color, and we're going to go ahead and set it equal to our hover color. And what we'll also do is we'll go ahead and update our alpha. And so we'll do our button, we'll do set alpha, and we're going to go ahead and set it equal to 1. And then when our mouse leaves our game object, we want to do the inverse. And so what we'll do is we'll reset our alpha back to our 0.4 that we initially set it to. And then we're going to go ahead and set it to our color that we provided. And so now if we come back to our game, we can see now when we hover in and out on our game objects, the color gets updated. And so it's very clear to the user that they're interacting with that game object. All right, so now that our game objects are interactive and we can see our hover events working, the next thing we need to do is we need to start building out our core Simon game logic. And so what we're going to do is we're going to create a class to keep all of our logic that's tied to the specifics of Simon. And we're going to kind of treat our main file here as the UI of our game. And then that way our class will be reusable. And if we ever want to use it in a different framework, we'll be able to do so. And so to go ahead and do this, what we'll do is in our source folder, let's go ahead and make a new file, and we're just going to call this Simon, and we'll do .ts. And let's go ahead and export out our class. We'll export default class, and we'll call it Simon. All right, so for the game of Simon, what we'll need to do for our class is we basically need to mirror how the gameplay actually works. And so for Simon, what happens is we generate a sequence of IDs that the player needs to go ahead and remember and then play that sequence back to us. And so for our class, what we're going to do is we're going to create a very simple array that's going to keep all of the numbers for our sequence. And basically we'll need a method to go ahead and generate the next number in the sequence. We're going to need a way to check and track which buttons or sequence IDs the player has provided back to us and make sure it matches the expected sequence. And so we'll need a way to track to know if the game is over because they messed up the sequence. And we'll need a way to handle our player input. So that's what we need to do at a high level. And so for our class, we're going to go ahead and add some properties to keep track of some of this data. And so the first one we'll do is we'll add a private property. And we're going to call this current sequence. And this is going to be a number array. And we're going to go ahead and set it to an empty array initially. Then we'll want to keep track of the player moves. So as our game progresses, our player needs to provide us 1, 2, 3, however many buttons, and we'll need to know how many they've already provided to us. We'll need to keep track of that. And so this will also be an array of numbers. And then finally, we need one property to know if our game is actually over. And so if the player ever provides an invalid sequence, we would go ahead and set this to be equal to true. So then that way we'll know the game is done. And so we're just going to go ahead and initialize this with false. So then let's go ahead and add in our constructor. And basically what we'll want to do is we'll want to go ahead and initialize our game right when it starts. And by initialize our game, basically we're going to reset all of our data here. And then that way we can go ahead and allow our player to reset the game. And then we'll also want to go ahead and generate the first item in our sequence. And so to go ahead and do all this, we'll make a new method. And so we're just going to call this initialize game. And what we'll do is let's add in our new private method. And so we'll do Go ahead and copy that. Go ahead and paste it. And so inside here, basically we want to go ahead and reset our current sequence. So we'll set that equal to an empty array. We'll reset our player moves. And then we want to go ahead and generate the first element, the first ID in our sequence. And so we'll do this. We'll call this a new method. We'll do generate next sequence element. And let's go ahead and add this new public method. And we'll just go ahead and call it public. All right, and then so in here, we're just going to go ahead and add a comment for to do. So then what we're going to do is let's go ahead and add in our getters so we can get some of these properties from our class. And so after constructor, let's do get sequence. And now what we're going to go ahead and do is we're going to add some getters. So then that way we can reference some of this data over in our phaser scene. And so the first one we'll do is we'll add a getter for our sequence. And so for this, we'll return our number array. And what we'll do is we're just going to return a clone of it. So then that way we don't return a reference to the same array. And so we're just going to use our spread operator, and we're going to go ahead and reference our current sequence. Then we want to go ahead and add a getter for it knowing if the game is over. So we'll do get, and we'll have get is game over. This will return a Boolean, and we'll just return this game over. And then we'll need a way to know if our sequence is actually finished. So in the game, like if we do the pink button and our player pushes the pink button, we know they're done. If we do like pink and then green, we need to know when the player has pushed both of those buttons. And so we're just going to do a getter. We'll do get player sequence complete. And this is going to return a Boolean as well. And so we're just going to do return this player moves dot length is equal to this current sequence dot length. And then finally, we're just going to have a public method if we want to go ahead and reset our game. And so we'll do public reset game. And this is basically just going to reinitialize our game so we have back to our starting values. And so one more public method we need on our class is we're going to need to be able to check a player's move once they click on one of our buttons. So we'll do check player move. And for this, we'll have one parameter, and it'll be X, and this is going to be a number. And so this is going to represent our button ID that we push, and we need to check that against our sequence. And so we're just going to add to do for this as well. All right, so now we have our core structure in place for our Simon class. The next thing we need to do is work on generating a random element for our sequence. And so in Simon, our rounds or our sequences is basically the sequence of buttons that the player needs to press in order to keep playing the game and in order to get their high score. And so when we generate a sequence or a round, what we need to do is we need to keep track of our existing sequence that we have. So when the game starts, there's no elements. And so if we have this pink button, this will be the first item in our sequence. Then after the player presses that button, they've gotten that right, we need to generate the next sequence. And so the next sequence is going to be the pink button plus any one of these buttons here. And so we're going to need a way to generate a unique identifier for what button we need to press next in our sequence. In addition to that, for our method, we'll want to go ahead and reset what we're tracking for our player moves because a new round is starting and we need them to start from the beginning. And so for our game, what we'll do is we'll have an ID for each of our buttons. So 0, 1, 2, and 3. And we just need to generate a unique number in that range. So what we'll do is in our public method, let's go ahead and get rid of our to do. The first thing we're going to do is we're going to check to make sure our game is not actually over when this is called. So we'll do this. If our game is over, we're going to go ahead and throw a new error. So we'll do throw new error. And what we'll do is we're going to go ahead and add an enum to the top of our class to keep track of our errors. And so we'll have enum, we'll have Simon error, and for this enum, we're going to do invalid move game is over. And we'll just set this equal to a string. We'll do game has already ended. Please reset the game state. So then what we should be able to do is now down when we throw our error, let's go ahead and reference our enum, and we'll go ahead and reference our invalid move game is over. So if the game's not over, we'll want to go ahead and reset our player's moves. And so we'll do this, we'll do our player moves, and we'll set equal to an empty array. And now we need to actually go ahead and generate our sequence. And so for this, we're going to go ahead and push a new item into our array. So we'll have our current sequence, we'll push, and now we need a way to generate that random number. And so we're just going to make a new function. We'll do get random int inclusive, and we're going to need a min and max value for generating a number in that range. And so we'll have 0 and 3 to represent our range of button IDs. And then what we'll do is let's define this function at the top of our class. So we'll come up to the top. Let's go ahead and do function. We'll have our function. Let's add in min. So this will be a number. We'll have max. It'll be a number. And this is going to return a number. All right, go ahead and generate a random number. We're just going to go ahead and do return. We're going to use math. We'll use floor to go ahead and round. And then we need to go ahead and grab a random number. So we'll do math, we'll do random. We're going to go ahead and multiply this by our max minus our min. And then we'll add 1. And we'll go ahead and add in our min. And then that way we're going to generate a random number. And it'll be between our min and max. And it'll also include those. All right, so now we have our method for generate random element. Next, we need to do is actually handle our player input. So back in our class, we'll come down to our check player move method. First thing we'll do is let's make sure our game's not over. If it is, we're going to go ahead and throw an error. All right, so for our player moves, what we want to do is we want to go ahead and add this to our player moves array so we keep track of where they're at in their sequence. And then we just want to make sure that the last element of that sequence actually matches what it's supposed to be. And so to go ahead and do this, we're going to do this, we'll do our player moves, and we're going to push in the value that was provided. So now we just need to grab the last element in our array and make sure it matches where it should be in our sequence. So what we'll do is we're going to do this, our is game over, and we're going to set it equal to this, our player's moves. We want to grab the length of our player's moves array, and then subtract 1 so that way we have the last index. And we're going to set our game over if this does not equal the same index in our current sequence. And so we'll do our current sequence. We'll do our player moves dot length minus 1. So we grab the same index. And if they're not equal, then our game will be set to over. And so one last thing we're going to do is we're just going to add a safeguard where if we've already have the number of player moves and it's equal to our sequence, we're going to go ahead and return and not add anything else to our player moves array. So if our player moves dot length is equal to our current sequence dot length, then we want to go ahead and just return. And then that way, once we have the number of moves equal to our current sequence, we're going to expect the game to go ahead and call our generate next sequence element method. All right, so with that, we should have our core logic that we need to actually play our game of Simon. So real quick, what we did is we created a core class here for the game of Simon. We added in our properties to keep track of our game state for Simon. And so basically it's the sequence of the game that the player needs to match. We have our player move sequence, which is the input the players provided to us. And then just a simple Boolean to know if our game's over. We then added some getters to grab references to these properties, and then we added some public methods that we'll need for interacting with our game. The first one is our reset game, which will also initialize our game, basically reset it back to the initial state. And then we have our generate next sequence element method. And this is just used for generating a brand new round or sequence where we start adding additional IDs, buttons that need to be pressed into our sequence. And then this will be called repetitively until the game is actually over. Finally, we added a player move method, which just allows us to take an ID of the button that the player pressed. And then we just make sure that based on where they're at in their current sequence, it matches what is expected. And if not, we go ahead and say that the game's actually over. So now that we have our core Simon class, the next thing we need to do is we need to connect it to our scene, and then we need to introduce some simple state tracking. So in our game, basically we need to know when our game starts, and so when it gets initialized, we'll need to know when we're playing a sequence to the player, and then that way they cannot provide input until that full sequence is completed. Because what we're going to end up doing is we're going to play a button, we'll highlight it, we'll play some sound, and there's going to be a little bit of a delay while that happens. Then we'll go to the next button, then the next button in the sequence, and so on until the sequence is finished. And only after that sequence is finished would we allow the player to provide input, and we need to know that we're waiting for them to do something. Once the input's done, we would go back to our playing sequence state, and then finally, when the game's over, we'd be in a done state. And so by adding the simple state, it's going to allow us to easily lock input in our game, and to track overall what's happening. And so to do all this, we're going to go ahead and make a simple object for keeping track of our state. So let's go ahead and copy our asset keys object, and we'll go ahead and rename this to be game state. And then for our states, let's do initial. We'll do playing pattern, and we'll do waiting for input, and then we'll do done. And then what we'll do is let's go ahead and update all of our values to match our keys. And now what we'll do is we're going to add a property to our class to keep track of our game state. And so we'll have game state, and that's going to, and then we need to go ahead and get a type. And so what we'll do is we're just going to add a new type. We'll do type, we'll do game state, and it's going to be equal to our key of, type of, our game state object. And then that's going to allow us to use that for our type. So we can do game state, and it's going to restrict it to these keys here. And while we're here, let's go ahead and add in a property to keep track of our Simon game. And so this is going to be an instance of our game Simon. And now what we need to do is we need to initialize these actual values. And so we're going to go ahead and do that in our init method. And so what we'll do is we'll add init. And basically what this method is going to be invoked when Phaser initializes our scene. So it's going to be invoked one time, and it happens before our preload method. And so it's really good for setting up anything in our game that's not tied to the game objects themselves. So it's perfect for us initializing our array. So like our buttons will set to an empty array. Our game state, we can go ahead and set our initial value. And so we'll go ahead and do game state, we'll do initial, and we can go ahead and create an instance of our Simon game because it's not creating any Phaser 3 game objects. All right, so now we have our game state. Now we need to go ahead and actually play out our sequence. So when we create an instance of our Simon game, we call our initialize game method, which generates our first element. So what we're going to want to do is in our create method, after we create our button game objects, we need to go ahead and grab our sequence of our game, and we want to go ahead and play that out to our player. And basically when we play the sequence, we want to grab that ID, and for that button, we're going to go ahead and highlight it, and we can go ahead and play a sound. Then what we'll want to go ahead and do is after a delay, we'll go ahead and reset the alpha and the color, and then we would go ahead and play the next element in our sequence. And we basically repeat this until our sequence is empty, and then that's how we'll get our game actually working. And so go ahead and do this. We're going to go ahead and add a new method. And so what we'll do is let's come to the bottom of our class, and we're going to go ahead and add a new async method. So we're going to add async, and it's going to be private. And so we'll do play sequence. And we're going to go ahead and return a promise, and we'll have void. And the reason we're making this asynchronous is so that way we can have a small delay while our button's highlighted and between our buttons when we show them. Otherwise, the game would play too fast for our player. And so when we play our sequence, we need a way to have our game wait. And so what we're going to do is we're going to introduce a sleep function that's going to allow us to do this. And so what we'll do real quick is let's go ahead and go into our source folder. Let's make a new file. We're going to do utils.ts, and let's export a new function, and we're going to call this sleep. And so for sleep, we're going to expect one parameter. It's going to be milliseconds. This is going to be a number. And all we're going to do is we're just going to wrap set timeout in a promise. And then that way we don't have to have a bunch of callbacks in our code. And so we're going to return a new promise. And so we'll have resolve, and we're just going to call set timeout, and we'll specify resolve for our callback, and we'll have milliseconds for our timeout. Then back in our main.ts file, let's go ahead and call our sleep method, and we're going to go ahead and sleep for a second. And we'll need to go ahead and call await since it's returning a promise. So now we want to go ahead and get a reference to our actual sequence. We'll do const, we'll do current sequence is equal to this, our Simon game, and our sequence property. And now we just need to iterate through that array. So we'll do for, and we'll do const number of our current sequence. And then what we'll do is for each of those numbers, we need to grab that relevant button that matches that and update its fill color and alpha based on that ID. And so in order to do this, what we need to do is for our buttons, we need to store on that button what ID is associated with it. And so to go ahead and do that, what we're going to do is we'll reference our buttons array, and we're going to use that number as our index, and that way we get our reference to that game object. And so what we'll do is we're going to call the set alpha method, and we're going to go ahead and set it equal to 1. And then what we'll want to do is we'll want to go ahead and play our audio sound. So I'm just going to do to do play audio. And then we want to go ahead and sleep again. So we're going to go ahead and sleep for another second. And then we'll go ahead and reset our alpha. So we're just going to go ahead and copy this line of code. Let's go ahead and go back to 0.4. And then we just want to do a small delay. So we're going to do sleep. And we're just going to do 400 milliseconds. Then what we'll do is back up in our create method. We'll get rid of our console log. And we're going to go ahead and call our new method. So we'll do this play sequence. And we'll just add in our catch, but we won't actually do anything. We'll just go ahead and return undefined. And now what we should see is when our game refreshes, right away, our sequence should start. And so if we wait, we'll see our button, our alpha updates, and we play that item in our sequence. And so we can see our logic's working. However, what we really want to do is we also want to update our fill color to match our hover color when we're doing our highlight here. And so to do that, on each of our buttons, we're going to need to know what that actual color should be. And so what we can do is we can use Phaser to act as a data manager for each of our game objects and then store data on our game object. And then that way later on, we can grab a reference to that data and use it. And so basically in Phaser, the data manager is just a basic key value store where you provide a key and the value you like to set on that object. And it's a safe way for you to add additional properties without accidentally overwriting something that shouldn't be overridden on the game object. And so to go ahead and do this, we're going to come back to our create button method, and to enable the data manager on your game object, you need to call the set data enabled method. And this is going to tell Phaser to, hey, add the data manager to this object so you can store data. And then to actually use it, you use the data property, and then you go ahead and use the set method to provide your key and then your data you want to store. And so you can also provide an object, and then Phaser will apply all of those properties based on their keys to your data. And so that's what we're going to do, is we're going to go ahead and provide our object. And so for our object, we're going to want to store a reference to our color. We'll want to store a reference to our hover color, and we need to go ahead and give our buttons an ID, so then that way it's unique. And so for the time being, we don't have this, but we're just going to go ahead and call this button ID. And so then for our data here, we're going to go ahead and provide undefined. And so the reason we're doing that is when you provide the object, Phaser is going to go ahead and use these keys on your object as the key, and then the value will be the value of that property on the object. And so now for our button ID, we're going to go ahead and add a new parameter to our method. And so we're going to do button ID, and this is going to be a number. And then what we'll do is up here, we're just going to go ahead and provide those IDs to match our sequence we'll be using in our game. So 0, 1, 2, and 3. So then what we can do down in our play sequence method is we can go ahead and get a reference to that data and then go ahead and set it accordingly. So before we set our alpha, we're going to go ahead and update our fill color on our game object. So we're going to go ahead and use and set our fill color, and our fill color is going to be equal to our buttons array. We'll grab our index, and then we're going to grab the data. We're going to do values. And what this does, this returns all of the values we've set in our data manager. And then we can go ahead and reference our hover color. And it's going to be a number because we know that's what we set it to. And then we can go ahead and do the inverse of this after we reset our alpha here. But instead of doing our fill color, instead of doing our hover color, we're just going to go ahead and do our color. So now if we go ahead and save when our scene refreshes, now we get that nice effect where our buttons have that hover color that we expect. All right, so the next thing we need to do is we actually need to update our game state. So right now when our scene refreshes, we'll see we can hover over our game objects, and it interferes when we play with a sequence. So what we want to do is on our event listeners, we want to check to see what state we're in and make sure we're in the state we're expecting. So what we're going to do is we're going to just do an if statement, and we'll do this. Game state is equal to our game state, waiting for input. Then we'll go ahead and do our logic here. And so we're going to go ahead and save. Let's go ahead and copy that line and apply it to our other event listeners. And same thing for our mouse down. And then what we'll want to do is after we play our sequence and we finished playing everything, Then we want to go ahead and update our game state. So we'll set our game state to game state, and we'll be waiting for player input. So now when our scene refreshes, if we hover, nothing happens. But then after our sequence plays, we can go ahead and we can see our interactivity is working properly. So now that we have our initial logic working for playing our first item in our sequence, we now need to handle our player input. And so back up in our create method for our buttons, when we listen for our pointer down event, what we want to do is if we're in the state where we're waiting for input, we want to take our button's ID and then pass that to our Simon class to check our player's move. And if the move is now valid, what we'll want to go ahead and do is we'll play the next item in our sequence, and basically we'll go ahead and repeat. What we'll also want to check for is if the game is over, and if it is, then we'll go ahead and update our game state, so we'll finish our game. All right, so to go ahead and do this, what we'll do is let's get rid of our console log, and the first thing we're going to do is let's reference our Simon game class, and we'll do check player move. And so for the button that was clicked, we're going to go ahead and grab our data, and we'll do our values, and we'll go ahead and grab ID as number, and so we're going to pass that to our check. And then we want to go ahead and check to see if our game is over. So if our game is over, we're going to go ahead and update our game state. So we'll do this, game state is equal to game state, done. And we'll just do a console log for the time being so we can see that it's working. Game is over. And we'll go ahead and return. If the game is not over, then we want to see if our sequence is finished. And so if our Simon game is player sequence complete, then we want to go ahead and play our next sequence. If the sequence is not complete, we need the player to click on another button so we can keep building out that sequence. And so if it is done, then we're going to update our game state to be equal to game state, and we'll go back to playing our pattern. And then we're going to do this. We'll do our play sequence again. We'll do our catch, and we won't do anything if there's an error. So now what we should be able to do is we go ahead and click on the right button. Oh, we'll see it stays highlighted, so we need to go ahead and fix that. So after we check our player move, what we'll do on our button is we'll go ahead and set our fill color back to our initial color, and we're going to go ahead and set our alpha back to the value when we're done highlighting. And the reason we're doing that is because when we click on our mouse is still over that game object, and we don't want it to stay that color. All right, so we'll see now it plays our next item in our sequence. And it looks like it was yellow, yellow. Oh, and it looks like our, yes, so for our sequences, after we do our playing pattern, we actually need to call our generate next sequence in our element. So now what I'm going to go ahead and do is I'm just going to do a console log just to make sure this is working properly. So we'll do this, we'll do our Simon game, and we'll get a reference to our sequence. All right, so go ahead and save. We should be able to test our changes. So we'll see we have our first sequence. We click our blue button. Now we have blue, and then we have pink. And so if we do blue, we do pink. We get our next sequence. We have blue, pink, and then yellow. And if we just play it one more time, we should see another item get generated. And let's go ahead and click on an invalid sequence, and we'll see our game is over. All right, so one last thing we're going to do for our prototype is we're going to add in the ability to go ahead and play our audio objects. So what we need to do is when we create our button, we need to go ahead and pass a reference to which audio asset key we like to use. And so what we're going to go ahead and do is for each of our buttons, we're just going to go ahead and do our asset keys, and we're going to reference the various sound. So we're just going to copy this here. We'll go ahead and paste that for each of these. And so we're going to have 2, 3, and then 4. And then down here in our method, let's go ahead and add in our new property. And we're just going to do audio, asset, key, and this will be a string. So then what we need to do is we're going to go ahead and store that on our data that we pass. So let's go ahead and add that in. And now when we play our sequence, we want to go ahead and play that audio that's associated with that button. And so to do that, let's come down to our play sequence method. And for each of our items, after we go ahead and set up our alpha, we'll go ahead and do our audio. And so we'll just reference this. We'll reference our sound manager on our scene. We'll use the play method to play our sound. And then we just want to go ahead and grab our buttons. Then from our array, grab the correct button based on the index. We'll do our data, we'll do our values, and then we want our audio asset key. And this will be as a string. And then that way we can go ahead and play that audio. So let's get rid of our to-do. All right, so if we want to go ahead and test, what we should be able to do is refresh our scene, and then we should hear the audio for when our sequence plays. All right, with that last change, that actually completes our working prototype of the game Simon. So as I mentioned at the start of the video, the goal of this series is to just create a very basic implementation of our game with the basic game elements to make everything work. And so some ideas where you could take this game further and make it your own is you could add in a simple scoring mechanic. So then that way we keep track of the sequence and where the player's at for their score. We could add in support for a local high score, so persist that between sessions. Another idea is you could take your Simon game class, and because it's reusable in just JavaScript, you can make an NPM package and then reuse that with other frameworks like Contra, vanilla JavaScript, or even on the backend with Node.js. You could add in support for mobile, and so then that way we could optimize our screen here to take up our full mobile screen and add support for touch controls. Then to really complete the game, you could add in a title and a game over screen, so then that way when the player loses, we have a way to actually restart the game without having to refresh the page. And so with that actually brings an end to this video. So as a reminder, there is a link in the description of the video to the complete source code for this video. And as always, thank you so much for watching. I hope you enjoyed the content. If you did enjoy the video, please consider liking the video and hitting the bell icon to be notified when new videos are released. For more great Phaser 3 content, please see the links on your screen now.